Hello students, in this video we're going to learn more about logarithms. So if you recall, in my previous video I introduced logarithm and we saw what is the relationship between exponents and logarithm, and we also learnt about product rule and the quotient rule. Okay, so let us continue, but before before going to the topic, let us recap what I taught you in the earlier video. So the first thing is, if A power B, I'm sorry, say A power B equal to C, this implies the equivalent is log C to the base A equal to B, isn't it? And we also learned that when we talk about, let's say, log A to the base B equal to C. Okay, so let me erase this. So when you talk about this, we learned that this A should always be positive. What it means is we cannot find logarithm of a negative value. And we also saw that the base also has to be positive. Not just that, it should also be not equal to 1. This is another thing we learned. And the third thing is the C, the value of logarithm, belongs to R. What it means is the C can be any real number. It can be a positive number, it can be negative number, it can be rational number, irrational, it can be anything in fact. It can be even be 0. Yeah, this is what we learned. Now I told you that this B has to be greater than 0 here and not equal to 1, right? So let us say two specific bases. Let's say, suppose if we have something like log, let's say x to the base 10. Now when the base is 10, this is called as common logarithm. This is called as common logarithm. And in case if the base is e, let's say log y to the base e, when the base is e, then we call this logarithm as natural logarithm. I hope you know what E is. The value of E lies between 2 and 3. So approximately E is equal to 2.71. Okay. So this is what we learned. And also, in case if log, let's say x to the base A equal to log y to the base A, right? Then this implies that x equal to y. As you can see, log and the bases are same, therefore x and y, they are also same. And I told you that please don't think that we are actually cancelling log and log, and don't write like this. This is completely incorrect. Don't write like that. Don't cancel log. We cannot cancel like that. What I mean is, if log or logarithm of x equal to logarithm of y, and provided both of them have the same base, then definitely x and y have to be equal. That is what it means. And other way around, in case if, let's say, a equal to b, so let me erase this. In case, let's say, if a equal to b, then logarithm of a will be equal to logarithm of b, provided both of them have the same base. Let's say the base is c. Okay, so this is also true. Yeah. Now let us see the power law. Okay, what does it mean? It means log a to the base b raised to c can be written as c times log a to the base b. So what it means is this power c can be brought in front, okay, like this. So let us see an example. Log x squared to the base 10 can be written as 2 times log x to the base 10. Suppose if it is log y power 4 base 10, then what it means is I can bring this 4 in front, I can bring this 4 in front, so I can write it as 4 times log y to the base 10. Okay, this is what it means. Let us see a few more examples. Let's say same way, if I say 3 log, let's say z to the base 10 can be written as log z cube to the base 10. So I can even bring this 3 to the power of z. I can bring it here. Okay, that is also possible. Okay, what about this? What about log, let's say, root x to the base a? How can I simplify it? How can I use power law here? I can write it as log x power half to the base a, isn't it? X root x can be written as x power half. Now again I can bring this half in front, so half log x to the base a. So this is how I can write it. Let us see one more example. Let's say if it is log 1 by x to the base a. How can I use power law here? Very simple. I can write 1 by x as x raised to minus 1 to the base a, which is nothing but minus 1 times log x to the base a. I can bring this minus 1 in front. Okay, so this is the power law. So let us see some examples now. Okay, so let us see how to simplify this. I need to simplify log x cube to the base 10 plus 1 by 3 log x cube y power 6 to the base 10 minus 5 log x to the base 10. Now I want to make it as a single logarithm. Now as you can see, you might think that okay fine, there is a plus sign here and the bases are same, so I can use the product law. No, you can, but not right now. So what you need to do is you have to make sure there is no the coefficient of x, I'm sorry, the coefficient of log should be 1. So what do? I use the power law. So the next step is log x cube to the base 10 plus log x cube y power 6 power 1 by 3 to the base 10. So I use the power law minus log x raised to 5 to the base 10. So this is the first step. So the second step is this will be as it is. This will become log xy squared to the base 10 minus log x to the base, sorry, x power 5 to the base 10. Okay. So basically this will be nothing but log x cube to the base 10. So let me use the product rule here. So this means log of x cube multiplied with xy square to the base 10 minus log x power 5 to the base 10. Now I can use the quotient law, quotient rule. So I can write as log x power 4 y squared by x power 5 to the base 10. So this is nothing but log of y squared by x to the base 10. Very simple problem. Fine. So now let us simplify this expression. So what I'll do is I'll use the power law first. So this 2 I take it here. So I take it here. So I get log of x squared to the base 2 minus, same thing I'll do it here. So I'll take, it will become log of 1 by y power 4 to the base 2 minus again log xy power 3 to the base 2, right? So the next step will be log of x squared to the base 2 minus log of 1 by y power 4 minus log of x cubed y cubed to the base 2. Okay, so let us say first I use the quotient rule here, so I get log of x squared by 1 by y power 4 to the base 2 minus log of x cubed y cubed to the base 2. Okay, so again, so this will basically, what will happen is this 1 by y power 4 will become, x squared by this expression that you see here, this expression that you see here will actually become x squared y power 4, isn't it? So let me write that. So this will become x squared y power 4, right? So again, let me use the quotient rule. I'll get log of x squared y power 4 divided by x cubed y cubed to the base 2, so which is nothing but log of, I shall get y by x to the base 2. So this is the answer. Okay, so let us learn some more properties of logarithm. Let's say if I want to find log of, let's say 4 to the base 4, let's say I want to find what is this value. So as usual, let us take it as x. So my objective is to find the value of x. So write it in exponential form. It will become 4 power x equal to 4, which basically means x equal to 1. So let me find, let us say I want to find log, let's say 8 to the base 8. Same thing, I'll take it as x. So this implies 8 power x equal to 8, which basically means x has to be equal to 1. So from this you can deduce easily that log a to the base a will always be equal to 1. This is a very, very important property. Log a to the base a equal to 1. Okay. From this, what do we get, and when do we use this? Let's say I have 2. I can write 2 as 2 multiplied with 1, isn't it? So 2 multiplied with, I can write 1 as, let's say, log 3 to the base 3. So I can use the power law here. I can take the 2 to the power of 3. So I can write it as log 3 squared to the base 3. So log 9 to the base 3. So basically 2 is nothing but log 9 to the base 3. Likewise, I can replace this 1 with anything. I can replace it with, let's say, log 5 to the base 5, or I can replace it with log, let's say, 10 to the base 10. I can replace it with anything. Okay. And one more property. Let's say I want to find logarithm of 1 to the base, let's say 5. I want to find the value. Let me take it as x. Let us convert it in exponent form. 5 raised to x equal to 1. We know that 1 can be written as 5 power 0. So since the bases are same, the powers have to be same. So x equal to 0. So let us try to find log 1 to the base, let's say 12. Again, we take it as x. So I'll get 12 power x equal to 1, which can be written as 1 can be written as 12 power 0. Again, I get x equal to 0. So from this we can easily again deduce that log 1 to the base a will always be 0. So again, this is another important property. You keep it in mind. So what did we learn, students? We learned that log a to the base a will always be equal to 1, and logarithm of 1 to the base a will always be equal to 0. So these two we learned. Let us solve some problems now. The first problem is, in fact, let us learn 2 more important properties of logarithm before we start solving some problems. The first one is log a to the base b can be written as log a by log b, provided both of them have the same base. Let's say I can take it as c. Right? This is a very important property. So basically what it means is I can write log 5 to the base 2 can be written as log 5 divided by log 2. And the basis of both the numerator and denominator, the logarithm have to be same. Let's say I can take it as, let's say, 3. Yeah, I can take it as 3, or I can take it as 4. So it is a very important property. So let me show you an example as to when we use this property. Yeah. Suppose if I ask you a question, let me go to differential calculus. Let's say if I ask you y equal to log, let's say x to the base 4. So if I ask you what is dy by dx, students, many of you or some of you will answer incorrectly, saying that dy by dx is equal to 1 by x, because derivative of logarithm is 1 by x, log x is 1 by x, which is not true in this case. You might wonder why. Very simple. When y equal to log x to the base e, only when the base is e, only then dy by dx or the derivative of y will actually be 1 by x. Now you can see here that the base is not e, base is actually 4. Then how do we find the derivative of this function? This is definitely a function, so how do we find the derivative? This is where we use this property, what we learned just now. So you can write y as log x by log 4, isn't it, students? Yeah. Now I can write any base here, but I will write e, isn't it? Because I need to find the derivative, and I know that log x to the base e is 1 by x, so I'll write e and e. Now basically what you see here in the denominator is actually a constant. So it is basically like y equal to 1 by log 4 to the base e into log x to the base e. So let me differentiate it. So dy by dx equal to, so this is a constant, so I'll keep it as it is, 1 by log 4 to the base e multiplied with, now the derivative of this is nothing but 1 by x. So basically this is the derivative of this function. Yeah, so it is useful here as an example. Let us see the next property. Log a to the base b can be written as 1 by log b to the base a, like a reciprocal. Yeah, so it means that log 5 to the base 3 can be written as 1 by log 3 to the base 5. So basically the 5 and 3 interchange the places. This is another property. And the last one is a raised to log, let's say let's say x to the base a will actually be nothing but x. So what it means is I can replace, let's say, this x by log y, then this will also be y. Suppose I can replace this y with, let's say, this is a, let's say, sorry, let's say log, let's say some f of s, some function of x to the base a, then the answer will be, this will be equal to f of x itself. So basically something like this a log a completely vanishes. Now how is it so? Let us see the proof very quickly. Let's say I have a power log f of x to the base a. So let us say I want to find the value of this expression. Let me take it as, let's say, some y. Now let me take logarithm on both sides. So I'll get logarithm of a raised to log f of x to the base a equal to log y. So you can see my objective is to find the value of y here. Now using the power rule, I can bring this in front, isn't it, students? So I can write it as log f of x to the base a into log a. Right? Okay, sorry, I forgot to tell you something. When I take log on both sides, I need to take with the base a. Yeah, so I get log a to the base a equal to log y to the base a. Okay, now we know that log a to the base a is actually 1. This is 1, so I will get log f of x to the base a equal to log y to the base a. Now we know that since both of them are logarithm and the bases are same, f of x has to be equal to y. So basically this is nothing but, this y is nothing but f of x. Okay, so what does it mean? It means if I write 5 raised to log x square to the base 5, then it is nothing but x square. Suppose if it is, let's say, 3 power log x square plus 2 to the base 3, it means just x square plus 2. Same way, if it is e raised to ln of x cube, basically it means e raised to ln of x cube means log of x cube to the base e. So basically it means it's equal to x cube. So one more example, if it is 10 raised to log 5y to the base 10, so 10 and 10, so this is equal to 5y. Okay, so this is again an important property. Okay, so let us solve this problem. I need to find the value of x. First, you might think, okay, fine, you have the same base, right? And minus sign is in between. So you might think, let us use the quotient law. Please don't do that. First, you have to make sure, as I mentioned earlier, that the coefficient of log is 1, right? Here it is 2. So use the power rule and take it here. So I can write it as log of x squared plus 1 to the base 10 minus log x squared to the base 10 equal to 1. Now you can use the quotient rule in the left hand side. So this will become log of x squared plus 1 by x squared to the base 10 equal to 1. So let me write it in exponential form. So this will become x squared plus 1 by x squared equal to 10 power 1, which is 10. So I shall get x square plus 1 equal to 10x square, which means 9x squared equal to 1, again, which means x squared is 1 by 9. So I shall get x as plus or minus square root of 1 by 9, which is 1 by 3. Okay, now you should check whether both plus or minus 1 by 3 are the solutions for the given equation, logarithmic equation. How do you check it? Now very simple, we all know that when you talk about log, let's say a to the base b, this a should always be positive, isn't it? Suppose you can see a x here. So x definitely cannot be negative, so x cannot be minus 1 by 3. So the answer is x has to be equal to 1 by 3. This is the solution for this expression. I hope you understood the problem, how to solve the problem. Okay, this is the next problem. Here again I need to find the value of x. So what you can do is you can bring this log to the left hand side. So I shall get log of x squared plus 1 to the base 10 minus log of x minus 2 to the base 10 equal to 1. Now as you can see, both here the coefficient of log is plus 1. I mean, I'm not counting this minus here. So let's say plus 1. So I can, and the bases are same, so I can use the quotient rule. I get log of x squared plus 1 by x minus 2 equal to 1 to the base 10. Now let me write it in exponential form. So this I'll get x squared plus 1 by x minus 2 equal to 10 power 1, which is 10. So cross multiply, I shall get x squared plus 1 equal to 10x minus 20. So when you simplify this, you shall get this quadratic equation, x squared minus 10x plus 21 equal to 0. So let me solve both. Let me solve this quadratic equation. You will get x as 3 and 7. Okay, now you should check whether both of these values are solutions of the given equations. How do we do that? Now, as I mentioned earlier, this expression has to be positive. Now, you can easily check that when you substitute both 3 and 7 instead of x here, you will get positive values. For example, if you substitute 3 here, this will become log 1, and this will become log 10, isn't it? So both of them are positive. So for this particular problem, for this particular equation, both 3 and 7 are solutions. Okay, this is the next problem. Let us solve this. In the left hand side you have two terms, log x to the base 2 minus log x minus 1 to the base 2, and the right hand side you have one term which is actually a constant. So what I'll do is, in the left hand side I can use the quotient rule straight away. So I can write it as log x over x minus 1 to the base 2 equal to, in the right hand side I can take this 3 to the power of 4 using the power rule. So I'll get log of 4 cubed to the base 2, which is nothing but log of 64 to the base 2. Now, as you can see, you have logarithm, and the bases are also same. So which means these two expressions will also be equal. So I'll get x over x minus 1 equal to 64. So which is equal to x equal to 64x minus 64, which implies I'll get 63x equal to 64, which implies x equal to 64 by 63. So this is the answer, and as you can see, 64 by 63 is 1 point something. So this, when you substitute it here, this will be positive. Again, this will also be positive. So 64 by 63 is the solution for this logarithmic equation. Okay, so let me solve this problem. This is quite interesting, this particular problem. What I can do is, before using, you can see the bases are same, that is 3 and 3, and there is one plus sign in between. So you might think, well, let us use the product law first, product rule. No, before that you have to use the power rule. This 3, as I mentioned earlier, the coefficient of log has to be 1. So let me take the 3 to the power of x. So I shall get log of root x to the base 3 plus log of x cubed to the base 3 equal to 7. Now I can use the product rule now. Log of root x multiplied with x cubed to the base 3 equal to 7. So let me use the convert it into exponent. Now root x into x cube is nothing but x raised to 7 by 2, isn't it, students? Which is equal to 3 raised to 7. Okay, so my objective is to find the value of x. Now if a power n equal to b, it implies a equal to b power 1 by n. Of course, there are some restrictions for a and b. Let us not go into that. So basically what it means is, if I say x cubed equal to y, it means x equal to y power 1 by 3. Same way, if I say let's say x power 2 by 3 equal to y, then x will be y raised to 2 upon 3. So that is what it means. So same way I can use the same rule here. I will get x will be 3 power 7 raised to 2 by 7. So I'll get 3 squared, which is 9. I can cancel 7 and 7. I'll get 3 squared equal to 9. So the x is 9 here. The value of x is. Okay, let me solve this problem. Now log x squared to the base 2 equal to log x to the base 2 the whole square. Now I've seen many students commit this mistake. What they do is they feel that the right hand side we can use the power rule. I can bring the 2 in front. So they write this as 2 times log x to the base 2, which is completely wrong. So please don't do that. Only log x squared to the base 2, then that 2 I can bring it in front, right? This one is wrong. I can't bring this 2 in front. It's not possible. So how do we do this? Very simple. What I'll do is I'll use substitution. But before that, I will bring the 2 in front. So I'll get 2 log x to the base 2 equal to log x to the base 2 the whole square. Then what I'll do is I'll take this log x to the base 2 as some let's say some a. Then what I'll get is this will become 2a. 2a equal to this will become a squared. So we shall get a squared minus 2a equal to 0, which implies a into a minus 2 equal to 0. Again, which implies either a is 0 or a is 2. Now my objective is to find the value of x. So this a is nothing but log x to the base 2 equal to 0, or that means I'll replace a with this log x to the base 2 equal to 2. Now this means if I write it in exponential form, x equal to 2 power 0, which is 1. Here x equal to 2 power 2, which is 4. So the value of x is either 1 or 4. Right? Now there is a similar problem. Let me give you a similar problem. Let's say the problem is log x cube to the base 3 equal to log x to the base 3 the whole cube. Right? Suppose this is the problem. Now you can try this on your own. You can pause this video and start solving this problem, students. Okay, let us solve this. So I can bring this 3 in front, so it will become 3 times log x to the base 3 equal to log x to the base 3 the whole cube. Right? So I will replace log x to the base 3 with some a. So this will become 3a equal to a cubed, which implies a cubed minus 3a equal to 0. So let me take a common. A multiplied with a squared minus 3 equal to 0, which implies either a equal to 0 or a squared equal to 3. Again, which implies either a is 0 or a is root 3 or a is minus root 3. Now again, my objective is to find the value of x. So a is nothing but log x to the base 3 equal to 0 or log x to the base 3 equal to root 3 or log x to the base 3 equal to minus root 3. Okay, so which implies I can write this as an exponential form. X equal to 3 power 0 equal to 1, or x equal to 3 raised to root 3, or x equal to 3 raised to minus root 3. So this is what we get. Okay, let us solve this problem. Log x to the base 2 whole squared minus log x to the base 2 minus 2. Here, as you can see, it looks like a quadratic equation in log x. So what I shall do is I'll replace log x to the base 2 with a. So we'll get a squared minus a minus 2 equal to 0. Very simple. It's a quadratic equation. When you solve, I'll get either a as 2 or a as 1. Now replace a with log x to the base 2 equal to 2 or log x to the base 2 equal to 1. This implies x equal to, write in exponential form, 2 power 2, which is 4, or x equal to 2 power 1, which is 2. So 4 and 2 are the solutions of this particular problem, right? Very simple problem. Okay, let us solve this problem. Log of 3x squared plus 10x to the base x equal to 3. So there is only one logarithm, and so let me write it in exponent form. So I'll get 3x squared plus 10x equal to x raised to 3, which if you simplify you get x cube minus 3x squared minus 10x equal to 0. So you can factorize, you'll take x common, you'll get x squared minus 3x minus 10 equal to 0. So either x equal to 0 or x squared minus 3x minus 10 equal to 0. Now we know that this is not possible, isn't it, students? Because if x is 0, then the base will be 0. And we know that when we say log a to the base b, this b has to be positive and the b cannot be equal to 1. So this is very important. We need to remember this. And also this a should be positive, isn't it? A should be always be positive. Okay, so this answer is not possible. Now when I solve this, we'll get x equal to either 5 or minus 2. Now again we know that since the base cannot be negative, so this answer is not feasible. So the answer is x equal to 5. For this particular problem, x equal to 5 is the solution. Okay, this is the next problem. Log 2 power x plus 1 minus 8 to the base 2 equal to x. So let me write it in exponential form. This will become 2 power x plus 1 minus 8 equal to 2 power x. So the objective is to find the value of x. Now 2 power x plus 1 can be written as 2 power 1 into 2 power x, isn't it, students? So I will bring this 2 power x to the left hand side, so minus 2 power x equal to, I'll take this 8 to the other side, so it will become plus 8. So this will become plus 8. Again, I've seen many students make this mistake. 2 into, they think that this 2 power x minus 2 power x is 0, which is incorrect. Okay, you cannot just subtract like that. So what do? It's like this is 2 power x. How is it so? I mean, I'm saying this whole expression is 2 power x. The reason is, just look at this. Like say we know that 2x minus x is 1x, right? Same way, 2 times 2 power x minus 1 time 2 power x equal to 1 time 2 power x, right? So I'll get 2 power x equal to 8, but 8 can be written as 2 power 3, so which means that x has to be equal to 3. Very simple problem. Okay, this is the next type of problems. How do we find x here? I can very well write 3 power 2x plus 1 as 3 power 1 into 3 power x the whole square. Now you might wonder how. Very simple. 3 power 2x plus 1 means 3 power 1 into 3 power 2x, which means 3 power 1 into 3 power 2x, I can write as 3 power x the whole square, right? So that is how we got it. So I write minus 7 times 3 power x plus 4 equal to 0. So I'll replace 3 power x with some a. So I'll get 3a squared minus 7a plus 4 equal to 0. So let me factorize it. I shall get 3a squared. So how do we factorize it? So I can write minus 4a minus 3a plus 4 equal to 0. So I can take a common, 3a minus 4. I can take minus 1 common, and get 3a minus 4 equal to 0, which means a minus 1 or 3a minus 4 equal to 0, which will give me either a is 1 or 4 by 3. Right? So this is the answer, but my objective is to find the value of x, isn't it, students? So I'll get either a means 3 power x equal to 1, or which implies in fact x equal to 0, or 3 power x equal to 4 by 3. Then you can use the calculator to solve this problem. Now it's the same type, students, like the previous problem. So what I'll do is I will write this as 2 power 3 into 2 power 2x, which is nothing but 2 power x the whole square, minus 7 into, now 2 power x plus 1, I can write it as 2 power 1 into 2 power x plus 5 equal to 0. So I shall get 8 times 2 power x the whole square minus 14 times 2 power x plus 5 equal to 0. I'll do the same thing. I'll replace 2 power x with a. So I'll get 8a squared minus 14a plus 5 equal to 0. So you can solve this. Find the value of a first. It's a quadratic equation. Find the value of a first, then later replace a by 2 power x and find the value of x. Quite simple. Okay, so how do we solve this one, this exponential equation, students? Very simple. Let me convert this into logarithmic form. So this implies the base is 2. So for logarithm will also the base will be 2. The x, the power will become the value. That means this is equal to x, and the remaining expression, that is 14, will come here. So x is nothing but log 14 to the base 2. You can plug it in the calculator and find the answer. Very, very simple problem. Same way you can do 10 power x equal to 8. This is the next sum, next problem. You can write it in logarithmic form. So I get log 8 to the base 10 equal to x, isn't it? Very, very simple problem. Let us see some more problems. Let's say I need to find 3 raised to 4x plus 1 equal to 10. So how do you find x? Very simple. You write it in logarithmic form, so this will become log of this 3 will become the base of logarithm, and this 4x plus 1 will become the value of logarithm, and 10 will come here. So log 10 to the base 3. So once you find the answer, so 4x plus 1 equal to this answer. Let's say some number. Let's say, for example, let's say a. Then 4x equal to a minus 1. So x will be answer minus 1 by 4. Right? This a is nothing but, I mean, this value. You can find the log 10 to the base 3 in the calculator and put it here. Very simple problem. So that's all, students. I hope you enjoyed watching this video. Thanks.